All right. So welcome. This is Wise Up on Air Hands On. And I'm Damien Kaspauer, Software Product Manager here at Audiokinetic. We've got an exciting episode today talking about ReaWwise. And I won't spoil that for you. I will just move swiftly on to our special guests here joining us today. I'd like to welcome Bernard Rodrigue and Andrew Costa. Thanks for being here today, fellas. How are you doing?
I'm good, and you?
Doing
Very good.
Great. So I'm excited to dive into ReaWwise, hear more about what that is and how it connects people's workflows between Reaper and Wise. But before we go into that, I wanted to say congratulations, because for folks out there paying attention, Wise 22.1 has reached its full release. So congrats to the team at Audiokinetic and the community who helped us get here over the past 9 months of public preview and beta. So go grab it, get your hands on the new Wise 22.1. So with that, I'll ask you to introduce yourselves. Tell us a little bit about what you do at Audiokinetic.
I can start. So I'm Bernard Rodrigue. I am Director Wise Experience. I've been working at Audiokinetic since 2005. I'm focusing on Wise authoring and user experience, and also focusing also on WAPI, and also everything that surrounds Wise authoring in general.
Great. And by WAPI, you mean Wise Authoring API. And a question on my mind is, do you still have the cowboy hat from the time we spent in Austin at the Game Developers Conference?
Somewhere at my home.
Fantastic. Fantastic. Well, it's great working alongside you, Bernard, and congrats again on the release. Go ahead, Andrew.
Hi guys, so obviously my name is Andrew. I've been working as a software developer in the audio industry for about 8 years. I've spent the last 1.5 of those at Audiokinetic. I've mainly been working on ReaWwise and the Wise VST plugins. That's it.
Awesome. It's been so great to have your focus on these aspects that we've been building here as a bridge between our Strata multi-track libraries and Wise. So I'm excited to get started with that and introduce people to ReaWwise. A week ago, we had a deep dive into Strata, hosted by Simone Ashby here, head of product at Audiokinetic, and Simon Pressey. Dig back into the archives and get the full download on what Strata is, and take it away. Let's jump into ReaWwise and talk about how that speeds up the pipeline between DAW and Wise.
Okay. So what we have at the moment here on the screen is a Reaper project in Wise. So we have Reaper in Wise, and this Reaper project is actually taken from the Strata library, which is available from the website, and it's one of the free sample that you can download on the website. So, and this project is called Servo Stutter. It's about robot movements, like mechanical things moving. So we will be importing stuff from Reaper to Wise, and we'll try to learn a bit how ReaWwise is working and through a few examples. So let's start. So what people do in general in Reaper when they want to bring sounds into Wise, well, they first need to go through the render settings and then set up things. And once it's set up, they render files and they end up on a folder, and then they drag it to Wise. That's the classic way to bring files to Wise. It works, but I think we can do better. So that's a bit why ReaWwise exists. So let's try to do something very simple with ReaWwise, and just to understand how it's working. So let's bring ReaWwise from the extension menu in Reaper. And what we see here is the interface ReaWwise, of course. And on the top area, we see, well, right there on top, we see that it's connected to the current project that we have open on the side. And we also see it's going to import to a work unit, which is in this case the default work unit. And just there, we have the structure that's going to be created after the import. In this case, we have at the moment only a sound SFX, and it's using a wildcard. So just before we go deeper, let's take a look at the render setting side by side with the ReaWwise interface. So Reaper is going to export in this scenario 6 files. So if we click here, we see we have 6 files, and for each of these files, actually ReaWwise is going to run this entire structure here and create a sound for it. So we see here the actual file is going to be generated by Reaper and associated sound according to the template or the structure definition on top. At the moment, it's using a wildcard called region. So if we look here, we have actually a bunch of regions in this project, and what we have selected here is 6 regions. So as you see, as I'm selecting regions, ReaWwise updates, but let's start with those 6 for the moment. So we see we have 1 sound per wave file created. And so let's try this. So we have Wwise open on the side, and let's click transfer. So I did import in the past, so I'm going to overwrite the files and click close. So what we have now is the 6 sounds created in Wwise. That's good. That's already an improvement from dragging files from a folder. But I think we can do better. What do you think?
Yeah.
Okay. So let's undo that. These 6 sounds, they are actually variations on a type of sound. So in this case, this is a movement, a robot movement for slow, medium, so slow movement of a medium part of a robot. So there's 6 variations on the same type of sound, and usually in Wwise, we want them organized in a random container. So, well, let's create a random container in ReaWwise. So let's click plus button and click random container here. I'm going to call it my random for the demonstration. You see here that preview area is showing us the random container and the 6 files. So I'm going to transfer that right away. So it's working. So we have our random container created and our 6 sounds inside it. Okay, so now what happens if I select more regions here? So we see here we have all of our 6 initial sounds. The Reaper ReaWwise detects that they already exist, so they're in gray, but we have also the blue one here. They don't exist. But if I import that, what's going to happen is all of our sounds are going to be under the same random container, which is not what we want. We want all we want 2 distinct random container in this case. So how do we fix this problem? So at the moment, if we see here that this Reaper project has the regions organized in groups, and the first group of region is actually surrounded by markers. We see here slow, small, slow, small. So all of these regions are surrounded by a slow, small marker. So let's use this marker as a wildcard to define the name of the blend container. Oh, okay. So now we see the preview in ReaWwise. And we have slow, medium, and we have a 6 variation, slow, large, 6 variation. So let's try to, well, let's first delete our previous import in Wise and re-import everything. So let's try this. Okay, that's exactly like what we want. We have our 2 containers and everything organized into it. So let's try to select all of them in ReaWwise. We see our blue here. We already have a couple imported. That's great. So overwrite. So render everything. And now we have all of our containers created. That's very good. But probably in a game scenario, we would like to have a switch container. So yeah, let's try that. So let's click the button here and use the switch container. Where is it? The switch container. And for this, we will use the project name, which is the Reaper project name. So let's delete everything again. Now we see on top, we have our switch container, which is, the name is taken from the Reaper project. So overwrite. There we go. So we have our entire structure created now. Well, that's great. But since we're making a robot game, maybe 6 variation is not enough, because those sounds are going to be heard a lot of time. And yeah, let's try to improve this a bit by creating more variation. How can we do that? So far, we have been importing the master mix, the render of the master mix. So for each region of Reaper, we take the master mix of Reaper and we render, and then we send it to Wise. Instead of taking the master mix, let's try to use the render region, the region render matrix. So, and save settings. And if we take a look at the render matrix, we see here we have tracks organized. And at the moment, we have the render matrix to output 4 of these for each region. And those tracks are servo track, wearing track, pneumatic, and weight. So previously we had, I forgot the number, but we had a number of variation, 36 regions. And now with all of our tracks, if we look here, we have 144 sounds. Okay, but we have a problem here, because all of those WAV file, we have actually duplicate names, and Reaper was kind enough to have to number our files, but what we actually want is to get the track name into the WAV file. So every track render has a distinct name. Okay, now we have the track name in our WAV file, which is better. Let's save that. Okay, so let's delete everything we created so far in Wise and go back to ReaWwise. Is it okay, Damien? Are you following? Am I going too fast?
No, you're doing great. And again, the way you're building on these different strategies for getting things, from the Strata project and the regions, moving through the wildcards, and now expanding that to bring in additional variations. You're doing a great job. So I can't wait to see how this explodes now that you've got that all dialed in.
Mm-hmm.
Nice.
Okay. So switch container. Instead of playing a random container, it would, now when we have 4 tracks, we need to merge the tracks together. So we need to play a blend container. So let's try to create a blend container. We'll move it one down here, pick blend container. So the blend container will have the same name as the random container I had before, so we'll be reusing the marker name here. But for the random container, we actually we could actually use the marker and track. What's the result of this? Aha. Maybe we don't need the marker. Just track. It's going to be shorter. So we have, here we see, we have a blend container that has 4 layers, which themselves are random containers. And for the region, well, let's, to make the files a bit, the sound name a bit more unique, we'll, again, similar to the WAV file, we'll be using the track name inside sound name. So we have servo, slow, small, wearing, slow, small. Okay, so let's, I think the setup is right, so we can try this. Okay, so that's great. That's exactly what we want. So every time we play the switch container, it's going to pick one of the blend containers depending on the switch assignments. Each blend container is going to play 4 layers. It's going to roll the dice 4 times. For each layer, pick one of the 6 sounds, and the result is actually 6 by 6 by 6 by 6 number of variations. So a lot of variations. But it works. We have a lot of variations, but that the downside now. My programmer tells me, hey, we have too many sound in the game. Can we reduce the number of sound? Okay, well, maybe. Let's just try this. So let's delete everything, and now we'll just pick. Well, let's pick everything and then remove the 5 and 6 from the regions here. Okay, it's great. And then import again. So now we have a bit less files, and but still a large number of variations because of all the combinations. But
I love the way you went from like 144 files down to 96. You trimmed the number of assets there, and again, in response to the needs of the game. We could have done things like, excluding them in Wwise to prevent them from building, but having that additional functionality up front at the render stage as part of ReaWwise, incredibly powerful to be able to get exactly what you need into Wwise for your systems. So, nice.
And what we see here is the Reaper project contains all the information needed to build the structure inside its own data. So we're using the track structure, we're using the region structure and the markers to build all these structures in Wwise. So we're just mapping everything and creating this giant structure in one click with a single recipe. But okay, so now we have this. But we have a problem. So my programmer tells me, hey, we still have too much data in the game. And we see that all those files, they actually have silence at the beginning and at the end. So the end is, and this silence is a side effect of our Reaper export things, because the boundary of the rendered file is the region. And we have empty area here, and the resulting WAV file is going to include silence. But this silence is not welcome in the game, especially in a PCM or file. So how can we fix that? So what we did, so this is not, the next part is not in ReaWwise. This is a script we did this morning with Andrew. It's using WAPI. It's using the ReaScript system and ReaWwise to to communicate and send or call a script from ReaWwise to Wwise. So I'll make sure that first my selection is on the top container. And from the action menu, we created a script called AutoTrim Wise Selection. It's as simple as that. Just click this. Wait a few seconds, going to parse the WAV files. And after that, we can click here. And what we see now, we have the silence being trimmed out of the wave of the source file in Wwise. But there's a secret thing here. So if we only trim the beginning like this, we're going to create a problem because the silence here was actually useful to synchronize the different layers together. But you see here now the initial delay has been set to compensate the trim area on the WAV file. So the actual behavior of playing this container is the same as before, just less data in the game. Poof. And I think we have something now. Any question, Damien, or maybe on the chat?
We do have a couple of questions queuing up in the chat, but you're doing just a great job of showing very quickly how you started very simply and now have evolved this workflow into something that not only brings in an enormous amount of variation from the Reaper project to Wwise, organized in the hierarchy the way that you want it, but then dropping that script at the end to top and tail all of those variations and automatically put a initial delay offset in there. Come on, that's like doing the work of all day long in just moments.
So maybe I can just say a word about this script, and then I'll let Andrew talk about ReaWwise. So this script is a Python script. It's going to be published soon on GitHub. And actually, we'll talk more about this script in the next episode of the Wwise Up On Air. So it's a WAPI script, Python script, and it's being triggered by Reaper. So Reaper has when ReaWwise is installed, Reaper has an actually interface to WAPI. So Reaper can trigger any WAPI call in the Lua script of the built-in environment of Reaper. And this is like combining all these techniques together. And additionally, the script is actually also available in a context menu directly into Wwise using the custom commands or command add-ons. So we see here auto trim sources is actually the command that was added to Wwise, which triggered the WAPI scripts. So it's connecting dots together, making things work by magic.
Excellent, excellent. And we look forward to jumping into that deeper side of the Wwise authoring API with you in a couple of weeks. So stay tuned for that, folks. I'm going to bring this question in from the chat. The question is, is there the possibility to define the receiving Wwise object type via a custom wildcard? An example would be, say this folder is a blend container, this other folder is a random container. They're both sharing an actor mixer parent defined by another Reaper parent track. And this is from Maro Amburu. Thank you for the question.
I think I'll let Andrew answer this question.
Yeah.
What? I know the answer, but
Cool. And I'm saving up this other one for a little bit later in the presentation. But yeah, so great. Handing it off to you, Andrew.
So I'm not sure if I understood the question correctly, but we want to be able to, through the wildcard, define the container type. And at the moment, that's not possible because you can specify an object name with a wildcard, but the container type is done by selecting object type here in your Wwise structures. So yeah. So if
and the
if
other
your
side of that
wildcard
is that import destination that you have selected from your Wwise project. So that's the parent where that Wwise structure will be imported to. And we don't have the flexibility right now to specify different import destinations for different object types.
Yeah, that as well. Yeah.
Yeah, cool.
Yeah, now it's one import destination. You could put a wildcard in the import destination, so you could so that would technically make certain objects, depending on how that wildcard resolves, it would technically, things would end up in different import destinations. But yeah, that's more of advanced. It's advanced usage, I guess I would say.
Actually, have you? Yeah, and there's just an idea like this, because under the hood, what we can see is ReaWwise is using the same mechanism used for the import system in Wwise. Same mechanism as the tab delimited import. And maybe if we use, I haven't tried, but maybe it's possible to use this syntax over here where we use wildcards.
Yeah, that would work.
Yeah, so that's a hack. We never tried it. So yeah, that's a challenge we give to you and the listeners. Let's try. You can try to use the wildcards here using and if the wildcards would resolve to a container, a proper container type, it may work. So if, for example, the marker here was resolving to a random container, and then you have the name here specified, it might work or not.
If you click enter right now, the tree won't render correctly because it's it's expecting, like, it probably will use like a default object. You can try it. You're gonna get an error because Wwise is gonna say I don't know. So like so it doesn't know what type of object what type of container that is because it's obviously not a real container, because what is it name? So it's going to use a default icon. So it's probably the virtual folder is the default icon. You can see it here.
Yeah.
If you go ahead with this import, what's going to happen is that Wwise is going to say, I don't know what this container means. But if your wildcards resolve properly,
so like this, it could work. So yeah, it works.
Okay.
So we have a track named random container. You see I'm using the track wildcard into the syntax here. We specify the type and the name along together. And we see it's resolving to a random container with the name.
Yeah, it takes a bit of like mental juggling there to get all that to work, but there you go.
That was a good question.
Excellent, excellent. I wanted to take a step back to kind of re-explain the initial delay side of the script that you created. So for a question in the chat, this was, I'm not sure why the initial delay offset was changed after applying the trim script. So do you want to run through that again real quick?
Yeah, it's all about context and in what context those clips or WAV file are being used. And in this case, those 4 tracks, well, let's undo it. Yeah. So those 4 tracks are designed to be played together at the same time. And if we, and the silence of the empty area we see here is important because this is going to play, this needs to play after this one. So they have, and what is this initial delay trying to recreate is by removing the silence baked into the WAV file, which is the empty area here. We need to compensate so we maintain the sequence of clips during playback. So this is what the initial delay here is doing.
And
does that make sense?
I think that was a very clear representation. Let us know in the chat how that landed. The other thing about this is that when you render media for the game, what Wwise will render is the clip between the entry and exit of the source. So it will not render the entire WAV file that was imported from Reaper. It will only take the piece that's been edited.
Yeah, exactly. I did not specify that, but during the conversion step of generating sound banks, the trimmed areas will be removed from the converted files.
Perfect. I think that closes the loop really well. Nice, nice. Hopefully that landed out there in with folks.
Andrew, did you have any plan to talk about the template, or I do a demo?
You can talk about it. Sure.
Okay, but I have something else to talk about, maybe.
Okay, great, great. I'm going to pause on a couple other questions that are in the chat until the transition time, but go for it.
Okay. So, well, it's good because now we talked about the initial delay, but another way to create variation is to introduce randomization in the initial delay. So maybe a variation of this playback here is just to offset a couple pixels the clips, so when you play back, they don't exactly play back the same way every time, and well, we can do that. So in Wwise, first thing we need to do is set up a template. So let's create a random container. We'll call it random template, like this. And for the random template, we will use the randomizer feature to create randomization on the initial delay. So just a little bit, just to tweak a bit the sequence and the sync in the playback. So maybe 10 milliseconds. Or yeah, maybe 20. I don't know. So every time we play this, a container like this is going to offset a little bit randomly. So save this, go back to ReaWwise, and for our random container. So if you recall, the random containers are being played back. At the moment, we play back 4 different random containers at the same time. And if we say here, use property template, and we select the container that we created, so we select it in Wwise, and we use this button, which takes the selection in Wwise and bring it to ReaWwise. So now, every random container we create through ReaWwise is going to use a template instead of creating an object from scratch. And you see here, it says apply template only when new objects are created, but it could say always. So let's try this. And I did not try it before, so let's do a live test, see if it really works. So we're going to import everything. So let's see. It works. So you see, we have our initial delay with the randomizer orange, which means the 0.02 is actually now properly propagated into all of our random containers. Every time we play this blend container, it's going to sync the things a little bit randomly, creating even more variations. And last thing I want to show is an improvement on this, maybe RTPCs. So if on our template we have RTPC on volume, and maybe we're using LFO, and we move this like this, create a few points. Okay, and let's save this. And now let's try again to import our structure. And then close. So all of our, you see here, all of our random containers have the RTPCs copied from the template. So that was the last part of the surprise.
Awesome. Great run through of the template system. A question coming in from Nicola. Can we control which properties of the template object are applied to the newly created object?
At the moment, not in ReaWwise. So ReaWwise is going to take the entire template and apply it to the destination.
Yep.
But what I can say is this template feature is actually using the base property system that was introduced in 22.1 and that was released yesterday. And is it or before yesterday? I'm a bit confused. So if I take, for example, this random template, I say copy, and I click, let's say, my blend container. So it does not have the RTPC yet. And I say paste properties. So this is bringing the paste property dialog, which is the new feature in 22.1. And this dialog is actually, it gives you control over which elements you want to copy over. So RTPCs, we see the RTPCs here. We also see properties that differ. We see that here we have a difference in the initial delay, but any other difference would also show up. And this can also be done on a selection of object, not just one object. Quick introduction to base properties.
Yeah, that was super high level, but a lot of power in that tool. Circling back to the auto trim script, does it find the zero crossings when it does those trims?
Yes, it does.
Okay.
Yeah.
Awesome. Great question. And again, super so again, to avoid the clicks and pops that happen when you land the cursor for that trim.
Yes. So the script has options to trim the beginning and the end. Also thresholds for indecibels, and also options for the initial delay, and also an option for the fade in, fade out.
Yeah. And so that, again, that script coming in a future update to our WAPI scripts. And if you haven't found those, we have a collection of them up on GitHub, correct?
Yes.
Great. And we're going to talk more about WAPI and WACL in a couple of weeks. Bernard will be back to go deep and hands-on with how to extend your workflow using those. So there's a couple of questions that came in around source control with these operations. So I think we're going to transition to Andrew's presentation, and if some of that will be covered there, we can allow the flow to happen and then circle back to it. Otherwise, we can address it now during the changeover.
Yeah, I don't think we'll be covering source control.
Okay, so here come a couple questions, and let's see how these land.
Yeah.
The question is, source control support. Auto checking out files if they're in P4 already would be really useful. This is coming from Alex Barnhart. Thanks for coming, Alex. Would be really useful to have that instead of having to track everything down manually. What's the support so far?
Yes, so it's supported at the moment. If you're using a project under source control and you import using ReaWwise, it's going to prompt you to add the files in on the Wise side. And so it's going to ask you to add, it's the same dialog that you see when you drag and drop a file into Wise. You can automatically add it for source control. And just a note, also we're working, it's for next version, but we're also working to make this completely silent and automated, so you don't have to click, but it's coming in a future update.
Cool, yeah. And that's kind of what I love working at Audiokinetic, is we're always carrying these processes forward, with great questions like this from the community and feedback that we're getting. So already moving in that direction. There's another one here. If your Wise exe is not saved in the default path due to a bespoke perforce setup, is it changeable? And that's from Grace. Hey, Grace. Good to see you.
Is it changeable? Not.
So the Wise
Yeah.
project path is something that we define in ReaWwise.
All right. So this path is not editable, not changeable. It's taken from the running instance of Wise. So wherever the project is on your disk, WAPI is going to detect it and make it work. The only thing we don't support at the moment is if you have Wise running on a different computer. So if you have Mac and Windows, at the moment we don't support communication. Even though WAPI supports it, it's not supported at the moment in ReaWwise.
Cool. I think that covered it. Grace, let us know if that landed in the right spot. Yeah. Mark Kilburn asks, you don't support it yet. Nothing to say at this time. Back to the, yeah, so again, will cross-machine functionality come at some point in the future?
Well, it's on the roadmap.
Yeah, so there you go. Back to property templates. Curious, coming from Tame R, can the property template assign items to switch types, i.e. switch assignments?
Not yet, and that's something we will be looking to. It might not be part of the property template, but we want to have the switch assignment part of the ReaWwise workflow eventually.
Yeah, great question there, and certainly something we're thinking hard about is that, assignment of switches within a switch container to help automate that process as part of your workflows, because it can be a big deal getting everything into the right place in your switches.
Yeah, it's all about reducing errors and reducing repetition, clicks, and getting the work done fast and clean with no error, so we can focus on content, not on clicking for structures.
Exactly. Well said, Bernard. And yeah, thanks. Great questions coming in from the chat today. Thanks for tuning in, and keep them coming as we flow into this next section where Andrew's going to go deeper under the hood with ReaWwise. All right, Andrew, we got some folks on it, paying attention and bringing you the hard questions today. So take it away and lead us there.
Thanks, Damien. How are we doing for time?
Oh yeah, we're doing great.
Okay, so I had prepared talking a little bit about taking a bit of a step back and why we built an extension for Reaper, but I think I'll be probably preaching to the choir, so I'm gonna skip that. We'll talk about like how we built it and how Reaper allows us to build things like this. So let's start with that. So the way we can build extensions in Reaper is via something called ReaScript, and it's basically a bunch of functions that are available to us, and that could be in C++, it could be in Python, and one of the more popular things is in Lua. So there's, I think, the last time I checked, there's almost 500 functions available. So functions to rearrange tracks, to get markers, to trigger renders. We could even kind of hook into the GUI system if we're willing to go that far. There's extensions to kind of do all kinds of things. Simple things like automatically coloring your tracks based off of track names, managing UCS naming convention in your projects. There's even an extension that allows you to flash subliminal messages to your screen periodically. I'm sure there's some people, for some people they need that. I don't know, maybe some encouragement or something. I think the last time I checked, there were almost 2,000 extensions listed on ReaPack, which is Reaper's package manager. So let's talk a bit about ReaWwise. And so ReaWwise is a C++ extension. The reason we did that is because, first of all, C++ is the language of expertise at Audiokinetic. Secondly, we wanted to reuse some of the code base related to Wwise, and it's pretty much all C++. The main part of the code that we reuse is the WAPI C++ client as part of the Wwise SDK. Yeah, so those are kind of the main reasons we did it in C++. So what comprises of a C++ Reaper extension? So like, what do we need to do? So to explain that, I'm gonna open VS Code here. So yeah, little warning, it's gonna get a bit more technical here. All the code that I'm showing you today is available in our GitHub repo. Maybe we can have a link to that after, so you guys can get to it. So what makes a C++ Reaper extension? So there's a couple of things. So the resulting binary needs to be a DLL, so shared library. We also have to follow a naming convention. That resulting DLL needs to be prefixed with the word Reaper. So in ReaWwise's case, it's Reaper underscore ReaWwise DLL, and we need to implement the DLL, or the entry point, basically. And, sorry, I'm going to show you guys what that's all about. So here's our entry point. Here's some C++ code. This is our entry point. Yeah, I'm not going to go super into detail with that, but the entry point is really where we kind of initialize things for our application. We could hook into callbacks into Reaper. We hook into the extensions menu. We register code to react to the menu system. So when somebody clicks ReaWwise, Reaper will notify us, and we check if it's us being called, and then we'll open our GUI window, and so on and so forth, stuff like that. Okay, so the next part, let's look at the project a little bit. Let's look at the structure. So I've cloned the ReaWwise project here, and we'll look at everything in the source folder, because that's where all the code we've written lies. Actually, before we go here, we'll look at what third-party libraries we're using first to get all this to work. And to display that, I'll actually look at the CMake lists file. CMake is basically helps us with our build configuration. It's basically the build configuration of our project defined as kind of as code. And yeah, CMake will build your solutions, and it's also cross-platform, so it kind of abstracts the solution files. You can actually just build the code base by calling a command in CMake, so that's helpful on build machines. You don't have to specify something different for Mac or for Windows. You can call the CMake command, and it'll build the underlying solution for you and trigger the platform specific compilers and stuff like that. All right, so let's look at the first couple of lines here. Let's look at the dependencies we're using. So the main dependency is Juice. For those who don't know what Juice is, it's a general application framework. It includes a framework for building GUI components, for file reading, to do stuff on the server. Basically what you need. Juice has it usually. It's very popular in the audio community because there's a lot of audio specific code that comes with it as well. So it's, ReaWwise doesn't do any audio manipulation, but a lot of us here are familiar with Juice because we use it on like the Wwise VSTs and stuff like that. So it just was a natural fit, and it's easy to use. It's it's object oriented. A lot of Reaper extensions are C++ extensions use the Win32 API directly, and it's a little clunky. You can do anything with the Win32 API, but it's a bit dated too. Yeah, and there's also like a personal preference there, at play. So yeah, so that's Juice. Then for testing, we're using Catch2. For mocking, in our tests, we're using trompe-l'oeil. The other dependency here is the Wwise, the WAPI client, which is called AK Autobahn, and we link to it in a different way. It's still managed by CMake, but it's not in the main CMake file. Yeah, so that's a bit about CMake and the third-party libraries, the third-party dependencies that we use. Okay, so let's look at some of these CMake projects, and they're one-to-one with the directory structure. So try to keep it simple. So let's look at, they're in a different order than the folder list here, but we'll start with this extension folder. So the extension folder basically contains all the Reaper specific code. So the application entry point that we saw earlier. We've also all the function calls to Reaper are done through in this project, and we're going to talk later about why we separated it like this, so we can see some communication with some of the Reaper API over here. Actually, where was that? Yeah. So I'll leave it up to you guys to kind of dig in here, but yeah, this is the main class where we interface with those ReaScript functions that are exposed by Reaper. All right, so the second folder is called Shared, and basically this contains all like the GUI components, all the business logic that's not connected to Reaper. So anything that's not Reaper is in here. So like the GUI is here, so we have like a UI folder, anything related to theme, helper functions, and then core elements like our WAPI client and communication with WAPI is done. It's all written in this project. So let's look at the third project, and it's called Standalone. And so now I want to just try to create a picture for you here. So we have the shared code, and then we have extension or Reaper, which is the Reaper specific code. And we did this on purpose. We really wanted to separate that out because eventually, or one day, we want to port ReaWwise to, let's say, I don't know, for example, Pro Tools. Let's say one day they give us all the information we need to do this sort of thing that Bernard demoed. All we'd have to do is just rewrite that sort of that layer that interfaces directly with the context we're in. So for ReaWwise, it's in Reaper. So that extension folder is written in the context of Reaper, but you could imagine or a different audio type of software that offers an API with all the information we'd need to do that transfer. We'd be able to just rewrite that layer that interfaces exactly with the context that we're in. And the main thing that facilitates this is an interface called .context. And like, for example, the implementation of .context, and we'll look deeper into .context. We'll look at the file to see how it works, but we have a Reaper implementation called Reaper context. So like that whole GUI window you saw, it's defined in the shared portion of the code. So that's kind of launched, and a context is passed to it. So when we're launching in Reaper, we're getting the Reaper context, and the application doesn't really know the context it's in. It's just making those function calls on the .context, and when it's in Reaper, it's the Reaper context that's kind of responding in that context. So what Standalone is basically it's ReaWwise, but launched as a standalone desktop application. And this is possible due to that separation. All we need to do is write kind of like a dummy context for being open on the desktop. And that could just be returning static data. And that's exactly what this stub context does. It's empty. I don't know why, but oh, it's a header file. And you can see for some of the information we require from the context, it literally has a static value, sometimes empty values. So the reason we built this standalone project is, one, to be able to easily test or do like fine-tune GUI things without like having to launch Reaper and launch the extension all the time. And secondly, to provide an example of how you can build ReaWwise in a different context if you're up to that challenge. And it's not too difficult. Okay, so the last project is the test project, and this contains basically all of the unit tests for the project. I don't have a number on the code coverage, but it's pretty low. But we're working to bring that up. Like there's a lot of things that could be tested, and then there's a lot of things that are hard to test because of the dynamic nature of being connected to Reaper and also being connected to Wwise. So it's like it's a big ecosystem. So it's not always possible to unit test some of that stuff, or to write. Those wouldn't be unit tests, but it would be hard to write tests in code for some complex stuff like that. Okay.
Great. And so this is like the 4 chunks of the ReaWwise extension that you're working with as you're developing it to ensure that that you have this extensibility, right? Should it be ported to other DAWs, as well as when you say unit tests, it's really this idea that you have these tests that you can automatically measure against to make sure that everything is still working as expected and passing these tests.
Yeah, exactly. So ReaWwise is open source. If somebody wants to maybe make a change in the commute and maybe submit it, they could kind of run these tests to make sure that they haven't, broken some of the core functionality. Yeah, so exactly.
Yeah, and that's kind of part of the cool thing as we've started out here with ReaWwise is making that an open source access that people can use it, as you said, as a starting point to understand what's happening and how to create their own extension. So great.
Yeah, I mean they can take this, break it, make their own flavor of a Wwise transfer. Maybe there's something really specific. We tried to be kind of pretty generic,
Yeah.
But there's always like some exotic workflow that we probably haven't covered. Or there's a perfect example of getting Juice to work in Reaper. There's just a general example for an extension too. So,
yeah, if you just want to change the color of the interface to hot pink, I mean, it's there.
Yeah.
Cool.
If you specifically want to do that, I mean, you can. There's literally a theme file where we kind of actually define a bunch of colors here.
Bam! Customize your ReaWwise. You got.
Actually,
yeah, go ahead.
We had somebody forked it and did that modification, and I think sometimes it's for more like accessibility or maybe a colorblind thing.
Sure. Yeah. Or just to match the lights in your room. We all got these studios with the speakers and the lights, and if I could just get my ReaWwise theme tuned to that, it's whoo.
You could change the color on interval, maybe do some. So
okay, that's
you could tie it to the RGB of your computer hardware or something. Yeah.
You're getting carried away now. All right, I'll let you back to it.
Yeah. Okay. So now that we looked at folder structure, we even looked at some code. We could keep looking at some code. Look at some of the core elements. What was this? Let's say we can look at some of the core elements, some of the code that's powering some of the primary features we saw in the extension. So one of the main things that is kind of cool that wasn't super obvious during the development stages, like how do we get Juice to work inside of Reaper? So there's a bunch of examples, obviously, of getting Juice to work in a VST. So we know Juice, and it works well in the DAW. There's nothing conflicting there, but we can't use those kind of vanilla workflows that those vanilla examples that Juice gives us on their GitHub and stuff like that. So let's look at that quickly. So that's done in the extension folder. This is done in extension.cpp. It's done in a function called, where's it? Give me a second. These pop-ups, VS Code. All right, so there's a function called onHook command, and so we register this function in the application entry point. So when Reaper hits, when the Reaper menu opens, it actually just kind of broadcasts it to you, and you can You can actually react to anything in the menu, in the main menu, but obviously you want to only react to the clicking of your menu item. You don't want to break other people's flows. Reaper is super extensible, and you can break everything if you really want. So we're going to be we're going to be a properly behaved extension and only react to when we're supposed to be open. So when that happens, we'll initialize the Juice GUI system. It's one function call. We create our main window, and this extension window is in the shared portion of the code. We add the extension to the desktop, and we become a child of the Reaper, the application handle Reaper gives us. And then we set ourselves to being visible. And from this point on, it's a normal Juice window, and it's the rest of the application is just a collection of Juice components. For people who are familiar with Juice, it might have looked kind of familiar when you saw the ReaWwise GUI, because most of the components are unaltered, like vanilla Juice components with the Wise theme, kind of a color theme kind of applied to it. So yeah, I thought that was a pretty interesting. It ends up being really simple. Yeah, so that's getting Juice into Reaper. So we'll look at the preview panel, because and I'll show it to you guys here. Yeah, Wise open. Just give me a second. There it is. Sorry, it was hidden. Okay, so one of the most important components, and probably the most complicated component, is really this preview window, because it kind of incorporates stuff from everywhere. It's pulling in data from the ReaScript API from Reaper. It's pulling in all your configuration here, and it's also fetching information from Wise, because we kind of want to let the user know if things have changed, if something's going to be recreated, replaced, etc., etc. So a lot of things happening, and it's kind of a real-time update. So yeah, we'll see how that works. We can't really get notified of changes from Reaper, but we can do some polling and some clever things to make this kind of feel real time. But first, let's talk a bit about this GUI component. It's actually not a vanilla Juice component. It actually combines a couple of Juice components. We have a table header here, a Juice table header. We have a Juice tree view, and then for each element in the tree view, we have a custom tree view item. And this custom tree view item kind of renders itself as a row, and it kind of reacts to the changes in the Juice table header. So I thought this was a pretty cool component at the end of the day. So it's like a tree constraint inside of a table, and yeah, it works just how you would expect. Opens, closes, columns can resize. You can't select elements yet. That is in the roadmap. Some people might want to copy this just for information purposes, and so on and so forth. Okay, so how does this work? So we're going to go back to the code. Let's look at what powers this, and it's in the core folder, and it's called DAW Watcher. Yeah, the name might not be super original, but finding a name is sometimes harder than actually writing the code. It's just a joke. So what does the DAW Watcher do? So in general, the DAW Watcher kind of queries Reaper to find out if anything changed. It's implemented as a Juice timer. So what we get when we implement the Juice timer is we implement a method called timer callback, so Juice will trigger this on the message thread at a time interval, and you set that up in the constructor here. Yeah, right here. Okay, so yeah, so let's get the timer callback function. So the application, for I think it's every 500 milliseconds, it'll basically ask the DAW context, which is Reaper in our scenario, if something changed in the session, because we don't really want to, we want to save a CPU over here. So we don't want to just blindly ask for all the information and regenerate that that preview every 500 milliseconds. We want to react quickly, but we don't want to we don't want to fetch all the information. So we ask Reaper, did something changed? And the way that's implemented in the Reaper context is Reaper exposes basically an integer that you kind of query this integer, and if it's changed, it means that Reaper something in Reaper changed. So then we call something called trigger async update. It pops a message on the message thread, which will eventually handle async update. And essentially what we're doing in here is we're kind of grabbing all the information, the things from Wwise, the things from Reaper, and everything configured in ReaWwise, and we're rebuilding that tree. I'm not going to bore you too much with those implementation details, but that tree that you see is actually something called a juice value tree. And what a juice value tree is, it's basically a tree that you can store any type of data in. So you can imagine, we're storing the parent container, and its children will be all the child containers, and it'll have their names and their object types. So we're basically creating that tree right here.
So every time it checks in, gets that integer update from Reaper, and something has changed, you go through, you validate all the different variables, concatenate all your strings, stuff them into that table, and redraw that table of values. So
at this point, we're still talking about just a tree, and it's just data at this point.
Cool.
And it's stored in the application state. And what ends up happening is that GUI component, the preview panel, is listening for a change on that tree.
Got it.
Because we might want to use that tree data for other stuff. So the tree changes. Yeah, the GUI component is notified saying, hey, something changed here. You got to repaint yourself on screen, or it's going to look broken. We want to update our data. Cool. So that's basically what happens.
Nice.
Yeah, so the next thing I wanted to talk about, and we're using it here, is that doc context thing I was talking about. And where do we use it? We use it right here. So we're getting the information from Reaper. We want to get out that list of rendered files, or what is to be rendered from your render settings, because the render hasn't happened yet. So we call get items for preview on the doc context. And Reaper allows us to know what's going to be rendered, so we can query that. So let's look at doc context. Let's see what it is. So we have the header called doc context.h, and this is basically an interface that the shared part of the code, so whatever, like the DAW watcher, for example, interfaces with that context specific code, so the Reaper code, and it could be another context, maybe Pro Tools one day, for example. So this is the contract between the shared code and that context specific part. The shared code says, this is what I need. I need to know if the session changed. I need however you do it however you have to do it. In Reaper, it's implemented as an integer. Maybe a different DAW will do something else, but I want to know true or false. Did the session change? I want to be able to get the session name. That's for other things. I want to be able to save the state of ReaWwise into the session. So when we reopen our session and reopen ReaWwise, I want everything saved. I want to recall it. I want the default to be where I was last. So saving and retrieving state. We want to be able to trigger a render, and we want to know what items are to be rendered, for example, and so on and so forth. So if any context, any audio application could give me this information, it basically means that ReaWwise can be ported to it. So that's doc context. And then the last thing, we saw this other stuff in DAW Watcher. We had calls. We were using, and I'll go back to DAW Watcher. We were making calls to WAPI, the WAPI client. Yeah, it's right here. I apologize if this is a lot of stuff here, and I hope you can at least pull out the general ideas of what's happening here. Like I said before, the code is available, so you can study it offline if you want to learn more. So yeah, so we call the WAPI client to get information about Wwise objects, because we want to know if are we going to be recreating them, are we replacing them, do they exist already, et cetera, et cetera. Let's look at WAPI client. Let's look at what we're doing here, because I had said that we had AK Autobahn, which is the WAPI C++ client, as a dependency. So why is there another thing called WAPI client in here? Well, it's because we can't directly use the AK Autobahn client, because sometimes we got to do extra business logic, or sometimes a business operation is a combination of many calls to WAPI. So the WAPI client here is more about business logic. It's more about, it'll assemble different calls together to get maybe more context about certain information. So you can look at a function here as an example, just in object. Okay, get objects, ancestors, and descendants. So this is a good example of something that might require more than one call. Actually, because in WACL, if we're using WACL, it's possible in one call, but WACL is not supported in WISE 2019. So to be able to support getting an object's ancestors and descendants, there's a function called get object ancestors and descendants legacy, and this will do multiple calls to WAPI. It needs to get the children. It needs to figure out its parents as well. So it's multiple calls. I won't bore you too much with the details. It's more about giving you guys an example of what we're doing in WAPI client. In WAPI client, we're also assembling the WAPI requests and responses, which it's a little verbose, so it's nice to have it kind of compact in here. And when we call these functions, we're just passing like an object path, like give me the ancestors and descendants of this object path. We pass it the object path, and the code here will take care of that boilerplate where we create the WAPI responses and where we extract information from the WAPI requests. Okay, cool. So, you know what? I think that's pretty much all I'm gonna say about the code. I mean, those were the most interesting parts, I think, and it showed everything kind of working together. So, like, these are kind of good. They're good examples of code to show. I'm not going to show you other code that does some boring things.
Yeah, it's great. So, but at this point, you've gotten what you need from WAPI with regards to all of the paths and names and types and all of these things. And at this point, all of that is accessible whenever that update happens and you need to redraw the GUI.
Yeah, specifically for this call, the get objects ancestors, it's the DAW watcher will call it, and it'll kind of like concatenate all, like it created itself a tree of what it thinks is going to happen in WISE, and then it's like, but let me go see what's in the import destination. Okay, and then it compares it, and it says, okay, well, I don't know, this random container that you want to create actually exists already. So if you do import, it's going to be replaced or it's going to be overwritten, and you have those conflict resolution options here, and you can kind of tell WAPI what to do. But for the sake of the preview, it's going to try to help you and tell you what's going to happen.
Yeah.
If you have. Yeah, exactly. Sorry.
Yeah, so it's great. So and this is all towards giving context to the user of ReaWwise about what will happen if they press the transfer to Wise button. So making sure that they have that full understanding that the ReaWwise extension has a lot of other handling around, what to do when something, has a conflict and not. I did have a question that came up along the way for me, and that's, so I get my good preview, I've got what I need, I push the transfer to Wise button, and is there output of that step that's delivered somewhere?
Yes. So we can try it out. Actually.
Okay.
So I think it'll work. Yeah. So let's hit transfer to Wwise. So I don't think any containers will be created here, but sorry. So let's do replace. How about that? We'll have more action in the output. So let's do that.
Yeah.
Yeah. Bernard kept just closing this window.
Fast through that one, but that window's awesome, right?
Yeah, this is an important window. I mean, it tells you a bit about what happened.
Yep.
There's like, you kind of need to know Wwise a little bit. Like sometimes when you're creating, like when you create a sound SFX, it might create an audio file source underneath. So this will actually tell you that. So sometimes you might you say, I'm only importing 12 sounds, but it'll create the sound object and the underlying audio file source. So it might say 24 objects were created.
Gotcha.
So if you're ever wondering about that, you click view details and you'll it'll open a browser, and whoops, it's open on my other screen. Give me 1 second.
Yeah.
Do you see it?
Cool. Yeah.
So you get a little bit of extra details of what happened. So like instead of dumping all this information in that little dialogue, wouldn't really work. As a step one, we've offered like a basic HTML table here, and it gives you information about what happened. The container, type, status, those the destination files. Sometimes Wwise might rename something because you're using the same name, or well, actually I think we catch that in the app, but there's certain things like maybe like you might want to sanitize a keyword. You might have used like a keyword that is used in Wwise. So we don't detect that yet in ReaWwise because it could be complicated. There's a lot of edge cases. You'll see it here. You'll see the end result.
Great.
So yeah. So if something was sanitized because you used a special character and it went through, it's because Wwise actually helped you out there and it removed it. It replaced it with an underscore or something like that. You'll see that in this report again. So I was probably good to put an eye on here and check it out.
Nice. Thanks for closing the loop on that question that I had. Here comes one from the chat about the Wwise project path. So up at the top, having a quick overview of how we get that path could be great, and maybe that would help with the question, and that is, are there any troubleshooting steps around ReaWwise not automatically recognizing the Wwise project path, despite both Reaper and Wwise being open on the same machine?
Yeah. So there's a couple of things. So what's happening behind the scenes is ReaWwise, it connects to Wwise through WAPI, but it's using WebSockets, so it connects to a port and an IP. So the first thing that's important is that the WAPI running in your Wwise project, and I think you can configure it. And you need to make sure that ReaWwise is connecting to the same port that's being exposed by WAPI. And
yeah, maybe in Wwise.
Yeah, let's look at Wwise.
Yeah, in the log also.
Yeah. So for general debugging, obviously you can look at the WAPI logs here. Any call that ReaWwise makes, whether it's fetching the project path, importing, you'll kind of see it in here. And
that's the logs view in Wwise.
Yeah.
Great.
Yeah, it's at the top right here. And yeah, I'm not sure why. Oops, sorry. Yeah, I'm not sure why it's not scrolling. Anyways, so let's say, so you got to make sure that ReaWwise connects to the proper IP and port. So some people might be configuring WAPI to launch on a different port. You can set up the WAPI, so you can set those things up in ReaWwise through a settings file. I can show you guys that quickly. So that's going to be in your app beta, ReaWwise, settings. Yeah, there you go. So there's a couple of things you can set up in here. There's the WAPI IP and WAPI port. So if ever something's going, so let's say you need to go on a different IP or port, you'd come in here, change it. You have to close Reaper because this is scanned at the beginning, and relaunch ReaWwise, and you'd be hooked up to another instance of WAPI or your instance of WAPI, but running on a different port and IP.
Perfect. That seems to have rung the bell over in the chat as a possible, peek under the hood of how they could resolve that on their own if they run into trouble. Thanks for that question.
Yeah, you can always take a look at the logs too. Look at that quickly. The WAPI calls are printed here. Certain things that we're doing. It's not super verbose, but you can also help with debugging.
Is there a minimum version of Wwise? So
there is a minimum version of Wwise, I guess. So the ReaWwise will connect to at least to Wwise 2019. I don't know about the specific major, but the official release it'll work with 2019. Some things don't work, like apply template won't work. But it's the UI will adjust itself. It's going to gray out what you can't do. So we try to at least have, like you'll be able to do a transfer even in Wwise 2019. You might not be able. You can't do page properties, and one or two other things. But that's the major difference between the 2019 hooking up to a Wwise 2019 or Wwise 2022. You don't need a different version of ReaWwise. It kind of dynamically figures out what version of Wwise you're connected to and kind of hides and shows things.
That's cool because now that 22.1 is out, everyone will move to that and be living in the future like the rest of us.
Yes.
Cool.
Yeah, obviously. Yeah.
Okay, well, I got a creative one for the two of you if you want to flex this question. You ready for this? Bernard, we're going to need your help on this one too, so I'll welcome you back for this question. This one's coming from Dale Crowley. Good to see you, Dale, and thanks for the question. The question is how to create a MIDI sampler instrument using ReaWwise. It seems like you could automate most of the process with the correct setup.
Yeah. There might be a couple things missing. Well, at the moment, ReaWwise can set certain properties like through the property template, but for a MIDI container, we will need to set like the minimum key, maximum key for a note, for a sound. So there's a lot of properties to set, and you might be more happy with one of the WAPI script we have written on our GitHub, and we actually have a Wwise Up on Air on that subject. It's a couple years old, and we demo a setup where we have files in a folder, and we create a MIDI, complete MIDI setup in Wwise, and everything is mapped correctly for MIDI, like the minimum, maximum velocity also, and notes. Everything is done automatically with WAPI and a Python script.
Yeah, so definitely dig back in the archives to our Wwise Up on Air featuring WAPI, and again the WAPI GitHub, which provides that. Again, it'd be interesting to hear whether you can get there faster with the implementation in ReaWwise. Right now, I remember that live stream, and bam, it was snappy fast once you had that folder of waves ready. So, yep. Cool. Thanks for the question, Dale. Always looking for ways to improve the workflows and tap into existing ways that workflows have been improved. So great to have your question out there. We dropped the link to the WAPI hands-on into the chat for folks to jump out and dig into. So thanks, Bernard. And 2 years ago, hands-on. We've been at this a while. It's great. It's great. Cool. Well, was there more to cover over on your side, Andrew? Something else you wanted to dig into?
Sure. Yeah, there's
Cool.
This is for the real ninjas, the Reaper ninjas.
Okay.
And, yeah, people that have maybe a bit more experience in WAPI. Okay, so we have ReaWwise here, and yeah, the talk was mostly about ReaWwise, but there's so much that you can do in Reaper. And what we've actually done, and there's going to be a blog article coming out in the next week or two. We've actually exposed all of WAPI inside of Lua. So when ReaWwise gets loaded in, there's some code that runs that registers everything from WAPI, basically to the ReaScript context, and other extensions can do this, and they're used as dependencies for other scripts. So with this dependency, you'd be able to basically pretty much do anything you could do with the Python WAPI client or just WAPI in general. So the next part of the talk, we're gonna actually really go hands-on. We're gonna write a few things, and this is basically kind of what powered Bernard's. He triggered a script that triggered something in Wise by hitting an action up here, and that was done through our WAPI Lua, through us exposing WAPI inside of the Lua context in Reaper. So let's jump into that. So actually, let's start. Why don't we just start off by looking at Bernard's the auto trim Wise selection action. So we're gonna go to edit. So does everyone see this? Damien, is it looking good?
Looking great.
All right, so it's perfect because it shows really the basics. So what we're doing here is, so Reaper is that global ReaScript object, and you can get functions that other people have created, or just the vanilla Reaper ReaScript functions. So obviously this is not vanilla. This is a function that ReaWwise exposes, and it's a connection to WAPI, passing the IP import. And if we get a success, basically we're going to build a WAPI request, and we have a bunch of functions related to creating AK-JSON objects, and people that are familiar with the AK Autobahn or the C++ client will be familiar with this. It just represents a JSON object. It's a little more verbose than in Python or other sort of scripting languages, but we were able to build that request this way. So all calls to WAPI usually need arguments and options. They could be blank, but you still need to pass them in. So what we did here is that we were passing arguments that have a value, a key command, and a value ak.autotrim. And this is the name of the command Bernard created inside of Wise that calls that trim script. So all we have to do is tell Wise about that we want to trigger this command. And the way we do this is we do a WAPI call, and we pass the AK Wise UI commands execute URI with our request to call that command called ak.autotrim. We're not passing in an object path or anything, because by default it'll just run the script on the selected objects. So I guess, can we do it again? Can we do it here? Are these trimmed, Bernard? No, they're not trimmed. Okay.
This one.
This one?
Yeah.
Okay. Okay, well, we can do the whole servo collection. Okay, so let's select it and let's run. Okay. And let's look at what happened. So, yeah. So all the heavy lifting obviously is done inside of Wise, and we're just through our WAPI being exposed in Lua, we're calling that command. Okay, so let's look at doing some other stuff, a little bit more involved. And for that, I'm just gonna open my script, my reference here. Just give me 1 second. All right, so let's do something that's a little bit more, a little bit more code on the Lewis side. So we're gonna do something. We're gonna get the selected object. Let's start off with that. Let's close this, or let's just shrink this. So I'm gonna click here, and I want to get this. I want to retrieve this object. I don't know why I would want to do that, but it might be something that you want to do. So it's pretty simple in WAPI. And so we're going to keep our WAPI connect. And we're going to start by building our arguments and options, just like you would do in Python or using the regular C++ client. What's really important for this call, and here, let me copy this code as well. We're going to copy the actual call because I'm going to show you the URI you need for this. It's just the UI.getSelectedObjects URI. And it takes in an empty arguments, but what's important is to configure your options. So which field do you want to return? And what I've done is I've set up my options array to contain path. So we just want to get the path back. All right, so we built our options, we do our call to WAPI, and the next thing we want to do is we want to pull out the result from our response. So to do that, actually, copy some of the code. It's easier than typing everything. So we have a way to get the status by calling get status on the result we receive from the WAPI call. If the status is true, that means that it was populated properly, and we can pull out our path. And again, we kind of got to unpeel the object we get back. The result is a map. So we unpeel the layers one at a time, and then we end up with a list of objects, because get selected objects actually can return you more than one object. So actually, why don't we test it like that? Let's select a few objects, and then we just print them to the console. So let's just run that. Oop, I didn't save it, sorry. So it ran the previous command. Okay, there we go. So when I click save, it saved the command and ran it. And basically, I'm getting the paths to the selected objects in Y. Sorry about that. Sorry, I'm getting mixed up. Anyways, let's get the point. Can we see it?
Yeah, looks
looks
great.
Hope you can see. I can't resize this part of the window, but I have my fast large, pneumatic, and then all the children of pneumatic.
Yeah, so that would be an easy way to get your hands on any of the paths for selected objects inside of Wwise.
Yeah, and like the point is not really about getting selected object. It's that literally I can do anything here. So I can, and we're not even talking about just creating objects. We're talking about any functionality in WAPI, whether it's like related to events and stuff like that. You can do anything. If it's possible to do in WAPI, you can do it here, basically.
Excellent.
And I'll show you something a little more complex. Is it okay if we do that?
Go for it. Keep going.
Okay, so I'm going to do something else. And for this, I think it will be better to start with a new Reaper project. No, we won't. We might need to do other demos with that project. Okay, so the next thing I'm going to do is I'm going to do something in like the other direction. I'm going to like pull some information. Well, I guess it's the same thing, but I'm going to. So before we're like importing things, so we're going from Reaper to Wwise, but can we do some sort of Wwise to Reaper? Like, so the next script I'm going to do is it's basically the script is going to pull the children of an object and create that structure as tracks inside of Reaper. So I don't know, maybe you started a project in Wwise and then you want to kind of scaffold your Reaper session. I know that Wwise objects don't always map one-to-one to the Reaper session, but maybe some initial you want to create some stuff in Reaper. Again, this is an example of showing the power rather than how useful the actual script would be. So let's do that. So we're actually going to use our get selected object functionality, but I've rewritten it to be a Lua function instead of just pop this window, this console window. So not super important to know what's happening there. But the next part is a little more special, a little special. All right, so let's do this. Let's connect. We're going to connect to WAPI. And so to build a structure inside of Reaper, we need to fetch the items that we've selected. Actually, the way this script works is you select one item and it'll pull in all the children. So maybe we can do this one. We'll start small, just the pneumatic. And what we expect is a track in Reaper called pneumatic, and then a track for each of these sounds. Okay, so let's start. So the first thing we need to do is, again, like in the previous script, we need to set up our arguments and our options. So we're going to use Wackle to basically select all the children of the object that we've currently selected. So we're using the get selected object function that we wrote in the last script, and we're using that to pull in the object we select, and then we're using that in another query using Wackle to get all the children. Just open this up so you see better. So here we're writing that Wackle query out. So we're using the path we get from our selection, and we're doing select this and the descendants. And like the script before, we're assembling our arguments. And then we need to set up our options. We need a little bit more information. We don't want just the path. We want the type and the name. I don't think we actually use type, but anyways, it's okay. We'll fetch it anyways. And then we're going to do our call to WAPI here. Yeah, okay, that's good. And the URI we're going to be using is the core object get. And in combination with the Wackle query, it's going to basically give us the selected object and its descendants and all these properties, the path, type, and name. Okay, so then we want to, again, we want to check the status. I'm not going to do any error handling, but you probably should do some error handling. We're going to kind of extract information from the result. This call returns basically a map that has a key called return, and the value is that list of objects. Okay. So next part, we're going to iterate through that list of objects. And I guess at this point, I'm just going to copy in the whole script because I might make a mistake by copy pasting. So we get the size of that array, so the amount of objects. And this script assumes that the list of objects comes in the right order. I don't know if that's actually always the case. Maybe Bernard could talk about that. But so far, every time I've tried it, it does come in order. And basically, I traverse that list, and I kind of check the depth of each object based off of the object path. And you can do that by just counting the slashes inside the element. So like something that's just one level deep will have the one slash. If it's two items deep, it'll have two of them. So I kind of figure out where I am in that tree just by looking at that. Okay. And so as I'm iterating through that list of objects, I'm creating tracks in Reaper. So this is a vanilla ReaScript function. If I'm also trying to see if I'm a child or like a parent, and you can set that up in Reaper as well. You can make a track a parent track, or you can exit a parent by going the next level up, and so on and so forth. If people are interested, I could kind of clean this up, and we can probably release it as in our repack repo. If people are interested, just to have an example of doing something. So if everything works out fine, we should have some tracks created in Wwise. So let's save this, and it'll run after I save. There we go. Look like something did not work in our tree structure. So what happened here? Oh, because of the audio.
Yeah, it looked like it grabbed the audio source there and nested that underneath the sound SFX.
That's exactly what happened. I wasn't expecting it because when I tested this out, I wasn't using sound SFX. But obviously, if you're asking for all the descendants of an object, you'll get those audio sources as well. So it kind of surprised me, but there you go. You also have the audio sources.
I mean, it did what did what you told it to do in a pure programmer, efficiency. And yeah, this is called iteration. We just work forward from here to get it exactly where we want it, right? So
yeah, we can just let's delete this and we could go one level up and see if it breaks or not. And there you go. It looks like it respected it. Now you had the same thing, but now it's pulled up to fast large, and you should have even the servo eventually, servo,
yeah,
and and so on and so forth. So just the power of having, ReaWwise is powerful, but like this is really like the next level. Like now you can build your scripts, completely in Lua. You have all of WAPI exposed. And that's it. Like the sky's the limit at this point too.
Great. So. And so you've got a blog post coming out about that functionality soon. So get subscribed over there on the Wwise blog side of things. And then when is this Lua binding available?
It's actually already available. It's just, I don't think we've marketed it that much because we're waiting for like blog articles and the support around it, because it's, there's no UI here. There's no, it's we need to see how it works. And that blog article is going to have, there's 2 examples, like a simple one and then a more complex one. And we hope that we can really let you guys know how it works. Yeah. And obviously, we're always open to answering questions, or you guys can post things on our GitHub too.
Yeah.
I'm kind of looking at that every day, and that can help guide you.
Great. Well, and like you said, it's really WAPI in ReaWwise. And so one thing that we'll be doing here in a couple of weeks is going hands-on with the Wwise Authoring API and Wwise Authoring Query Language with Bernard over here, who's going to be taking us through the power and functionality of those 2 features of Wwise. So exciting if you're looking to find ways to build automation and extend your workflows by using WAPI, WACL, and now expanding into ReaScript with all of that power and functionality. So looking forward to that December 8th, 3 p.m. Eastern time for folks out there. Cool. Anything else to say? Yeah, go ahead.
I was just gonna say that WAPI knowledge will really help you out in this context, obviously, because it's basically WAPI in Reaper. So once you get WAPI down packed, you can I'm excited to see what people do, honestly.
Yeah. I'm gonna get a quick commercial in for the next Wwise Up on Our Hands-On that we have coming up, which will go into the new 22.1 version of the Wwise Adventure game that we have updated with object-based audio support and some new spatial audio optimizations. That's going to be on December 1st at 3 p.m. I'll be joined by Mas Moretti and Tali Kakliklian. It's going to be awesome. We've done this kind of thing in the past with the Wwise Adventure game, going deep into the spatial audio of it, and this will be an update and refresher for folks with the new version coming out as part of 22.1. Cool. So this feels like it's been a great deep dive and overview of ReaWwise, going, through the functionality that exists in the extension in Reaper, as well as what's behind the scenes in the ReaWwise extension. And then here at the end, leveraging WAPI as extending that functionality. So thanks so much for bringing this to Wise Up on Air hands-on. Nice work, both of you. I wanted to carry back from the chat that they went and tried the wildcard in the import destination, and it worked. So they couldn't wait. They just had to get their hands on it while we were still streaming and wanted to let us know that they succeeded. So you didn't even expect that, and yet here we are. So incredible work empowering the community out there using Wise and Reaper. Thanks so much for going deep with us today.
Thanks to you.
Thanks, Damien.
Okay. Cool. Well, so tune in for the next Wise Up on Air hands-ons. We're just going to keep talking about all the cool things you can do to extend your workflows and leverage all of the cool new features in the box, the newly released full version of Wise 22.1. Thanks a bunch. Until next time, take care and see you soon.
Bye.
Bye.